Hi friends, I am Shravana and welcome back to my channel Sparkling Future. Before starting with today's topic, I request all of you to subscribe to my channel and also please like, share, comment and hit the bell icon for the latest video notifications. Thank you. Friends, today we will learn what is Big O notation. So, Big O notation is a mathematical notation used in computer science to describe the upper bound of the growth of the rate of an algorithm's time complexity, blah blah blah. Okay, this is the definition. But what exactly is the Big O notation? Big O notation means it's the comparison of two sets of code and making sure that both sets will do exactly the same thing. It's the way of comparing the codes mathematically about how efficiently they will run. So we measure the time complexity and same space complexity here. What are these time complexity and space complexity? How much time it takes and how much memory it will consume. Okay, that is the complexity. Now let's learn this with some examples. Now let's say you have a list of numbers like 3, 6, 7, 2, 4, 9, something like that. Okay, let's say you have this list. Now from this, right, let's say you are searching for some number. Okay, let's search for 3. When you are searching for 3 in this list, the first index itself, it will find the number 3 and it will immediately gives you the result, correct? Because when you are doing the linear search, like what will happen when you search first, it will compare this number. If it is matching, it will return. Otherwise, it will go to the next element in the list and next like that. It keeps on comparing whether whatever number we are searching is matching or not. In this case, when you search for 3, in the first index itself, it will find 3 and it will return very quickly, right? Means it will take very lesser time. This kind of immediate means if you are getting very quick results with the best possible input, then that is called as best case. Okay, so now what is the best case? Means when you are searching 3 in the list, immediately you get, means we will get the output within lesser time and which takes the less space also. In with respect to time complexity and space complexity, with very less time we are getting the result, then that is called as best case. Okay, and also in coming to the code, right, when you are writing some code, let's say there are some 5 or 6 if else conditions in your code. If the if is satisfied within the first condition itself, it will not go further into the nested loop, correct? It will first search for the if it is the condition is satisfied, it will come out of the if loop. So that first condition, if it is successful, then that is called as the best case scenario. Okay, and the symbol of the best case is omega, we can see here. This is the omega symbol. And similarly, let's say you are searching for 10. Okay, when you search for 10, what will happen first? The cursor will start from the pointer will start from the number 3 for index 0. Then 6, it will compare, is it matching with the 10? No. Then it goes to the next element, is it matching? No. Then the next element, is it matching? No. Like that, it searches till the end of the list and then it will find that 10 is present. So what will happen here means, here we have only 7 numbers. Let's say we have 1 lakh number or 1 crore number, and it has to, the program has to search each and every element to see whatever number you are searching is present in that list or not, correct? So because of if this 10 is at the last of the 1 crore number is 10, then it will take so much time to compare each and every element with whatever we are searching and to gives you the result. So such kind of case is called as the worst case, means which actually takes lot of time. This is the symbol of that worst case is O, big O notation. Okay, next, That is called as worst case. Then in between there are some average cases, right? For example, if you are searching for 8 or 2, then within it will not immediately return as 3, but it will not take as longer as 10. We're searching for the 10. So 8 or 2, or if for example if you are searching for 8, right, within the third iteration itself it will return. That is called as average case. Okay, and this is the notation for this is theta. So we have best case omega, average case theta, and worst case. So when you take the production code, right, when we are running the code, we always look for the worst case scenarios, because when we are trying to provide some solution for the problem, we have to first think about the corner cases. We have to think about the bigger problems. So let's say if it is A, then you cannot always think like only the if condition will be always satisfied and it will come out, right? We have to have multiple if else conditions to check proper way of finding the best solution. So because of that, we always consider worst case. Okay, consider the worst case scenarios. That's why big O notation has come up. Means this big O means is a capital O, which is omicron, and this is called as the big O notation. Okay, hope this is clear, friends. Now let's understand what is this big O notation. And like we have seen the like we have understand the introduction. What is big O means, it's the worst case analysis that we do, and what is the worst case also we understood. Now let's write one sample code to understand uh, how exactly the search will happen. Now let's say we have the same list. Consider the same list. Now we have to print the list, let's say. So now we are writing one simple code here in Python. Okay, now we are passing that list here. Okay, n means the number of items or something like that. Now for I in range of n, let's say we have some code like this. Then what will happen in this example? For example, you are passing n as 1. Okay, then it will print only 1. Correct? We can pass the same list, or I'm just considering by passing one constant as well, so that it will be easier for you to understand. Now let's say if you are passing 1, then it will print 1 and it will come out. Correct? It will take very less time. Now let's say if we are passing 10, then it will print from 1 2 3 4 5 6 7 8 9 10, and then it will come out. Similarly, if you are passing 1 lakh, it will run for 1 lakh times. So which means that whatever value you provide here in this n, those many times the operation will run. Got it, right? So this entire operation is dependent on the size of the n. Correct? How many times we have to run is determined by this constant n. So that's why we will calculate the complexity of this particular function is order of n. Okay, order means this is the usually for calculating the complexity of the big O notations we use as the terminology as order. Okay, so what is this n is how many times, this is for this particular function, this is the complexity. Okay, time complexity is order of n, means the when you analyze this particular algorithm, how many what is the n, right? Based on that number you will have the running time of it. So that's why it is directly depends on the value that we are passing here. That's why the complexity of this small code is order of n. Clear? Next, now let's say this example. Let's say we have one more loop like this. Okay, let's say we have code like this. So here what we have within the function, we have two different for loops, right? So here what will happen again, whatever the value you pass it here, first it will loop through this entire thing, which will become the order of n. Okay, and again here for the same range of n, one more for loop will run. So here we have 2 times order of n is happening. So what will happen? What is the total time complexity of this is order of n plus n, which is order of 2n. Okay, so you understand, right? So which means that 2 times the n is being, the iteration is happening. Okay, so if let's say you are sending 100 here, or 100 as the n value here, it will run for 100 times. Then again this for loop will run for another 100 times. So total it will become 200 iterations, right? So that's why we consider this as order of 2n. Okay, but here, so here 2 is the constant, correct? So usually as per this big O notations and algorithm analysis, usually we will drop the what to say, constants. So that's why it will become order of n. Okay, so now again for this also it will become order of n. Okay, now let's change this one a bit slightly and understand what will happen if we have the nested loops. Okay, so now this is the nested loop. Like we have a for loop here, and again inside we have a for loop, which means for each number in this, okay, for each number in the range, it will run this for loop as well, which means for 1 it will run 100 times, for 2 it will run 100 times. What is that 100 is the value that we are passing it here. Okay, then if it is 3, then for the 3 it is running for 100 times. So for the 100, then 100 into 100 times it will run totally, correct? So here what is happening is the quadratic expression is happening. So what we will write, because here already n times it is running and again into n times, correct? Because for each of this loop is running. If you can actually what if you wanted to have very clear understanding, you take a Python compiler, online compiler you get, and run this code, and you will see how many times you just pass some simple number like 10. So what will happen is for the I of 1, it will print 1 2 3 4 5 6 7 8 9 10, and again it will become the higher for loop will become 2, right? Then again it will print this 10, like that. So till it becomes 10, every time it will loop through this inner for loop. Okay, so now what's happening because of that, here we can see that the quadratic function is happening, means multiple times it is happening. So for this, that's why we say n into n. N into n is happening because for each n times the iterations are happening. So when it is n into n means the order of the, what is the complexity here is order of n square. Okay, order of n square. That is because we can see, right, it is getting iterated multiple times for each I in the range. So that's why the order is order of n square. And let's say we have 3 loops here. Here we have 2 for loops, right? 2 nested for loops. Let's say we have 3 nested for loops. Then it will become cubic order, right? So n into n, which is order of n power 3. Okay. You understand this one, right? So here 2 times n into n is happening because of the 2 for loops. We have considered that as order of n square. Now when you have 3 for loops here, it will become order of n cube. Okay. This is the order of this is the time complexity of these algorithms. Now let's say we have some let's take another example, like let's say how we have seen here, right? So now let's understand what will happen for this what is it, nested loop. Now let's take the same example. Now we have this example, and again we have another for loop under it. For k in range of n, print k. We will consider this as small simple operation. Now what will happen? For this we have seen the complexity is order of n square. Correct? Here we have seen clearly like why it is becoming the order of n square as the complexity. Okay. Now what is the complexity here? How many times n is there? Those many times it will print. Right? So because of that the complexity will become order of n. So what is the total complexity of this simple algorithm is order of n plus n square. Okay. So with that what it will become is order of n plus n square. This is the order of this one. Now if you take, there are some 10 items. Let's consider there are some 100 items. Okay. 10 items. I mean n is 10, let's say. Now when you just execute this particular order, it is saying that 10 plus 10 square is 100, which is 110. If you notice, the value of this is actually based on the highest value is coming from this square but not from here. Correct? So even though if this 10 is not there also, it will become 100, but there is not much difference between 110 and 100. Correct? Just try to understand this small thing, like the main value, the total value of this is mainly dependent on this value, that the highest value is coming from this n square but not from this n. Correct? So that's why while analyzing the algorithms we will ignore this, because this is the rule. Okay, like why we have to do means, when you are doing some analysis you have to understand some rules why we are doing that. Correct? So because this is the highest value, that is which is actually because of which the result will be different, but when you say this actually it's ignorable. Now let's say this as 100 sorry, n as 100. If you take 100 into 100 is this one. So now if you see, it will become this value. Okay, but if you, even if you remove this 100, it doesn't make sense, because already this 10,000 is a very bigger iteration value, right? 10,000 times the value is the loop is iterating. 10,100 means it doesn't make very big difference, right, when calculating the complexities. So that's why as a rule we ignore these smaller things. So now this order of n plus n square, again it will become like order of n square. Okay, so what is the complexity of this entire piece of code is, yes, correct, this is n plus n square, but as we have seen with the further analysis we found out that the value that is here is not adding much difference to the result, right? So we consider that as order of n square only. Okay, now let's take another example. Now as we say sum. Okay, sum nums, and we pass a single number. Okay, now just say return n plus n. Now what will happen? If you are passing 1 here, it will return 2. If you are passing 10 here, it will return 10. If you are passing 1000 here, it will return 20 2000. Okay, So how many whatever number as n you are passing as input to this function, it will perform only one operation, correct? Only a single operation here. There is no loop, there is no iterative items, it's just sum of within, correct? So this kind of function will be considered for the complexity as order of 1. Okay, what is the complexity of this is order of 1, because and it has this constant as 1, right? This always called as constant time. This word, the terminology, right, that we call it in the data structures and algorithms as constant time. Okay, now similarly, let's say if we have n plus n plus n also, like 100 times, if we add the n's also, it will still perform a single operation for the input that we are sending. Okay, that's why the complexity of this is always 1, and this is called as constant time. Clear? Next, now we have one set. We have taken one set here, right, initially. Let's take the same. Okay, now if we want to search for let's say the first number, as we discussed, right, 3, but now for the human eye we can see, right, 3 is in the starting number, but we don't know, when we are sending a list of thousands of numbers in the computer, we don't know in which index that 3 is present, right? So what usually we will do is, usually first this will be sorted, or most of the times we take the sorted list. Okay, 2 3 4 6 9 and 10, and most of the efficient or effective algorithm is, we will do the divide and conquer. Means here there are some 7 numbers, so it will be divided into 2 lists, 2 3 4 and 6 8 and 9 and 10. First step is dividing the entire list to 2 lists. This is list 1 and this is list 2. Now, and it will search whether 2 is present in this list or not. If it is present, it will return. If not, it will search in this list also. It will again search. But here, how it will happen is, let's say we are searching for 4. Then what will happen? First, it will divide this entire list into 2 lists. Okay, this is this one. And again, here we have this 2, 3, 4, 5. So now again it will be divided into 2 lists. Is the 4 is present here? No. 4 is present here? Yes. So first it will search here and then it will search here. So because of this, what will happen is, when we are dividing, instead of because this is what is that, sorted order, right? So 4 means that, let's say here we have in the second list it is 8. As 4 is lesser than 8, we don't have to search in this list at all. So this entire 3 iterations will be reduced, correct? We will not we don't have to iterate over this particular piece of list. So that way we can reduce the number of iterations, correct, here for searching the algorithm. So here when for anything, right, here we are doing the 3 steps here. First is, we are dividing this particular set, list, into 2 lists. Then this is the second step. We are again saying that because 4 is lesser than 8, this is the second list that we have tasted. This is the second step, identifying that 4 is present within this list and which is not in this second list. And the third step is again dividing this first list into half, 50%, okay, half list, and then searching. The 4 is not here, so it will return from the second list. Okay, now these are the 3 steps that we have performed. So usually how we will calculate the number of steps performed is, here we always take the base as 2, right? Because mathematically we always, I mean not always, but most of the times we take the base as 2. So here we have performed 3 steps for identifying this, so it will become 2 cube, which is 8. So which means that this is the number of steps it will have, I mean the number of steps that we do for finding out any number in this list of values is 8. So this is actually written in mathematical form is how we will write is log 2 of n, correct? This is how we write in the mathematical terms the same expression. Okay, now with this we will note the order of log n. So this is the complexity for this particular searching algorithm. Okay, got it? This is the order of log n. So here n can be any value. Okay, we divide the list into half and can search through them by performing lesser number of operations, and it also considered as a most effective searching strategy. Okay, so this is called as order of log n. And similarly we can take different inputs and different values, and then we can like identify what is the complexity of all these things. So now we have seen different examples, and we have seen how to analyze the complexity of an algorithm, correct? Now there are like we have without talking about this terminology, professional terminology, we just discussed about how to calculate this. Now coming back to the big O notation, there are these functions which are used for identifying the complexity of the algorithm. Now first one is the constant function. What is this constant function is? Yeah, so here this is what is called as constant function. Means whatever value that you pass, it will only run for once. This is the most effective algorithm, but we will not be able to use it as is in the production, but this is very effective algorithms because it takes very less time. Okay, this is the constant function. Okay, next one is the logarithmic function, which we have seen here, right? This is the logarithmic function. So this the logarithm, right, with the base 2, log 2 usually we say, right, is frequently used to describe the time complexity in the context of divide and conquer. Divide and conquer we have just discussed here, right? Let's say we have a sorted list and we are dividing it to 2, and then we are just searching if that particular value is there. Otherwise we will again divide it further into list, half of that list, and then we will do the searching. Because of this, what will happen, the searching iterations will be reduced, right? So this complexity is called as log n. Okay, so order of log base 2 also we can mention, but actually constants we will not use in the this one, right? So we say order of log n. This is the logarithmic function. And next one is the linear function. What is the linear function? Here is this is the example of linear function. Means whatever size of the input, right, those many times this particular iterations will happen. Like if you are sending n as 1, it will run only once. If you are running 100 as n 100 times, this loop will run. So this is directly based on the input size of this. So this is called as linear function. Okay, the third one, linear function. Next one is n log n. N log n function. Here we haven't discussed that yet because that is a bit complex algorithm. Complex means again we have to anyway learn it, the sorting algorithms, right? So for that it will come. So how it will look like is, okay, this is the way it will look like. So here the function assigns to an input, and how many what is the n value, right? What is this n value? Those many times again it will run. So we can say merge sort or heap sort are the examples of this. Like the similar way it will run, okay? Like here how we have done this divide, right? Division of, I mean, the splitting the entire list into half, and then again we will search here, and then we will search here, and once we found out, then we will again sort it. So here actually this is usually used in the sorting algorithm. So it will first search here, it is found, it will first we will split this list into half, okay? And within this half it is able to find out the one that we are searching, right? Then it will not search here. So if it is able to sort or find this particular item within this list, then it will merge and it will send. That is called as merge sort, okay? So in such kind of algorithms, this n log n time complexity, we can see that, okay? Next one is this quadratic function, fifth one. So it's nothing but this order of n square that we have already seen, okay? So here what is this quadratic function is, if the input size doubles, correct, the running time also will be more. This is the meaning of this. So this is called as quadratic function, means order of n square. And the next one is cubic function. Similarly we have seen how it will become order of n cube, right? Yeah, here, okay? This is the cubic function. Like the same thing, order of n cube, but there should be a name for these functions, right? These are the names for these functions. And finally the exponential function. The exponential function means usually it will look like this: f of n equal to b power n, okay? So there will be some value on top of it, some constant, okay? Here b, consider this b as constant, and n is the size of the input. So so it will be usually in recursive algorithms or Fibonacci series, if you see, right? How many times the size of the input is there on top of the same context, it's exponentially it will grow, correct? The value of this the total outcome of this, like the number of iterations or even the value of that, will grow based on the size of the input, right? So this is called as the exponential function, the last one. So these are the functions used for identifying the complexities while analyzing the algorithms, okay? Now just to be precise, the constant is 1, and for the logarithm we use log of n, for the linear we use n, for n log n we use n log n. This is the order, okay? The right side is whatever is mentioned is the order, and the quadratic is n square, cubic is n cube, and exponential is a power n. So here a power n, when we say a is the some constant and n is the input size. So how many what is the input size? Based on that, if you take this Fibonacci series or recursive algorithms, right? So there you will understand this exponential order. So this is about the big O notation and the how to calculate the complexities of the values. Hope this is useful to you, friends. Thank you for watching the video. Please subscribe to my channel for more interesting learnings. Thank you.